Any questions? We were good. First chunk, just make sure I assigned, yes, 1. We're good with number 1. And then 4 to 7 I assigned. Yes, you do. It's on the top of the stack over there. Okay. Nothing. We're good with number 4. We're good with number 5. We're good with number 6. Ria, you okay? We're good with number 7. No questions. Okay. So there's no question. What's going on? Oh, you need lead? Are there any questions? Nothing? We're good? It was all straightforward and easy? Okay. Number 8, I wanted you guys to do A through D. Questions about 8? We're happy with 8? Describe the missing or determine the missing values of y. What were your missing values for y in number 8? 6, 9, 12, 21, and 24. So if they tell you that it's linear, then the differences always obviously have to be the same. What was the equation that you guys came up with for this one? Sorry? Y equals 3x? Because each one of these is just 3 times the... I like it. That's good. So then C and D, well, D says to graph. We cool with the graph of y equals 3x using the table of values? Okay, hearing no issues. We'll jump to number 9. Number 9, I wanted you to finish the table of values and give me the equation for each. So this one I do actually want to talk our way through all of. What are the missing values here for 9a? 17, 20, and 23. Okay, so what is the equation for this relation? Yes, 10 meet. 3x plus 5. So you found 3x. You found the slope. So the ratio of the change in y over the change in x. Okay, so the change here was 1. The change here is 3. It's going to give you your ratio that goes in front of the x there. And then how did you find the plus 5? This is right. Y equals 3x plus 5. That is correct for this first one. You just went back? So a really easy way to do this is if you want to figure out what this piece here is, you plug your value in for x that you know. So in this case, 3 times 2 is 6. But it's not 6, it's supposed to be 11. So what do I have to do to 6 to get to 11? You add the 5. So the same thing here. 3 times 3 is plus what to get to 14? Plus 5. So that's where you're going to get your 3x plus 5 from. Does that process kind of make sense? Okay. The other way you could have done it, you could have graphed this thing, which I didn't tell you to do. And then this value here is just going to be the y-intercept, where the line crosses the y-axis. That's how I defined this last piece last class. B, what are our missing values? 7, 10, and 11. What's my equation? One over 2x plus, that's a 2, not 12. 1 over 2x plus 6. You sure? I think it's got to be 6.5. I think it's got to be 6.5. So again, this piece here, the part in front of the variable, comes from the ratio of change in y over change in x. My y's always go up by 1, and my x's always go up by 2. So that's going to give me a ratio of 1/2, 1 over 2. So now if I put this in here and I want to figure out, once I plug my values in, what do I have to do to add to get the appropriate y value? If I put a 3 in here, half of 3 is 1.5. How do I get from 1.5 to 8? You have to add 6.5. So that's going to give me this value here. Does that kind of make sense? Sort of? Not really? Someone give me something to work with. Who said not really? Okay. Why is it 6.5, not 6? So we're cool. Are we cool with it being y equals half x? We're fine with that? Okay. If you're not fine, I need you to say something. So I'll explain it again if I happily. Okay, we're cool with that. So then what we've got to do is this whole relation has to be verified by our table of values, right? So what I could do to figure out what I have to add by here is I can plug in an x value. It'll give me a value that I can compare to what I know it should be. So let's do let's do 3. Y equals 1/2 times 3. Half of 3 is 1.5, yeah? But when I plug 3 in, what should I be getting for y? I should get 8. So what do I have to add to 1.5 to get me the value I know I should have? I'm going to have to plug in 6.5 to get me my value of 8. So that's how we get, if I'm not graphing, that's how we have to get this additive piece in here. Does that help at all? Akam, does that help at all? Nika, kind of, sort of? All the shaking heads from the back corner I had earlier, does this help? Okay. So then C, what's my equation going to be? Oh, no, what am I missing? Values, first of all. -11, -1, and -5. Cool. Love it. So now what is my relationship, or sorry, what is the equation for this relationship? Okay, so let's take a look here. What is the ratio, or what's my change in y? It's -4. I'm going down 4. What's my change in x? +2. So then my ratio here is going to be -4 over 2, which is just going to be -2x. And now I've got to figure out what do I put in here, plus or minus something, to get me the values that I'm looking for here. The easiest one to plug in here is which one? 0. Because if I take 0 and I put, you're right, that's going to give me my +3. Because if I take 0 here and I put it in for x, and I'm going to get y equals 0. I don't want 0, I want 3. So what do I have to add to 0 to get 3? 3. So Akam is suggesting my -2x plus 3 is the correct relationship here. And then number 9D, what are the missing values? And then my relationship is going to be, or the equation for the relationship is going to be what? -3 over 2. This is gross. Minus what? Or is it +16? Let's find out, shall we? What value did you plug in for x? 4. We know it should be -10. What is 4 times -3 over 2? It's not 6. It's negative 6. What do I want it to be? So what do I have to add to negative 6? I have to add negative 4, or I subtract by 4. So that is what that value is going to be. Let's test it. What's 6 times negative 3 over 2? It's going to be negative 9. What do I have to do to get... Ooh, maybe we are wrong here.
It's positive 3 over 2. That's not possible because negative 4 is...
This is positive. This is positive 3 over 2. You are right. It's positive 3 over 2 because this is going up by 3. That's going to change everything. So 3 over 2x. 4 is going to give me, yeah, it is minus 16. You're right. Because 4 times 3 over 2 is going to give me 6, and I want to go down to negative 10, so it's minus 16. You're absolutely right. There you go. Love it. Well done, ladies. If you did not attempt these questions, you're going to want to attempt these questions. We're more and more and more, we're getting into mathematics that absolutely requires you to flex some thinking muscles. And if you're not willing to do that, it's going to become more and more challenging for you. Yeah, there's that. So, questions from the homework at all? Anything? Going once, twice, thrice, which is the name of a great band. Sold. Okay, flip the page. Let's do it. Today's lesson, solving a problem using a linear relation. We're not going to do the review because by looking at the homework, we kind of did the review. Actually, no, maybe we should. Here's what I want you to do. I'm going to give you a couple minutes now. I'm going to walk around, make sure we're all doing this. I want you to try doing it alone, no discussing with anybody else. I want you to fill in the chart, and I want you to give me the equation that relates those, or for the relation in the table. Do it on your own. I will come around and give you a hand if you need it. So give me complete the table and give the equation. And let's see how we do. I'm happy to assist. I would rather you put up your hand and say, I didn't do any of my homework yesterday, or I didn't do the question on homework yesterday. Can you help me now? There will be no judgment. I was trying to help you. Sure. Yes. It's the ratio of the change in y over the change in x. Yeah, it's always y over x. So the equation is it's always y, your dependent variable, is equal to something, leave a space, times x, your independent variable, and this is going to be plus or minus something, whatever number you have to do to add or subtract to tweak it. The thing you multiply x by is the ratio of the change in y over the change in x. Now ratio is just equal. So how is the y value changing? Is it going up or down by 3? Up by 3, so it's going to be 3 over, what's the change in x? 1, so 3 over 1, which is 3. So you're going to have y equals 3x plus something. figure out what that something is. Pick a value for x here, put it in, see what that number gives you, and then do whatever you got to do to tweak the number to give you what you want. So like an easy one here is to plug in 0 for x. Plug in 0, 3 times 0 is 0. But the 1 0 you want 2. What do I have to add to 0? 2. So it's going to be y equals 2x plus 2. Try with the next one. Armand, was that a hand? No, sorry. Coming up or old homework?
The old homework.
Okay, lots of you guys are done, so let's talk these through. What's the first one? Y equals 3x plus 2. Love it. The next one is y equals 2x minus. Anyone disagree? Can someone verify? Someone else that's not in the front corner verify they got the same thing? Ty says you're good. So does Acom. Okay, last one. One more time. Can someone verify that this is true? Someone who didn't work with the front corner? Okay. Okay, so if you struggle with any of those, let me know. Otherwise, we're going to keep going here. Today, we're going to look at solving problems using a linear relation. So it's going to feel like the same kind of problems that we did in not the polynomials chapter, but the chapter before. So-and-so has this many dollars, and how many books can they buy, or how many rides can they go on? That kind of problem is the problem that we're going to look at here with graphing. So, here's the question. A youth group of some kind, a gathering of youths, is planning to hold a carnival of some kind. The profit in dollars is 5 times the number of students who attend, minus the $100 they spent for the price of food. So, what's being suggested here is, so profit is, we understand how to get profit? Profit is all the money you make minus your costs. So somehow, it doesn't matter how many students show up, food's only going to cost $100, and they're charging $5 per kid. What is the equation that relates, or that can be used to find the profit relating it to the number of people who could attend? This is the kind of question that I would give you way back in like 2 chapters ago. So, what do we got? Carolyn. Where y represents what? Cool. Questions about how she came up with that? Okay. That comes from the same analyzing of words that we did 2 chapters ago. So, profit in dollars, you could call that P. Is. Mathematically, is what symbol or operation? It's equal to 5 times, so when we say times, we are multiplying by what? Number of students, which you could call any variable. I don't like S because my S's look like 5s. I would use X here because my S's look like 5s. And then it says minus $100. And there you have, just from the analysis of the sentence of the question, our equation. So now what we're going to do is we're going to create a table of values for this relation. X being the number of students, you can put that in here, and Y being money. So if this is my chart, currently empty, and this is the relation, now we're going backwards, we're giving the relation, now we have to create the chart. What values are we going to shove in here? What are some values that might make sense? We could put 50 in here. Let's put 50 in the middle. If the number of students, the thing that you can change, the number of students who show up, is 50, how much money are you going to make? 50 times 5 is 250. Minus 100 is $150. Okay, cool. Now we got to pick two more values. I want to make a note here on the right-hand side. You must have at least 3 points of data. To verify that something is linear, you must have at least 3 points, which is why this chart has three rows. So, give me another value. 70? Sure, why not? So, if the number of students is 70, what's my profit going to be? 250, good. Because remember, if we have forgotten what I'm doing here, I'm taking this value and I'm putting it in for the number of students in my equation and I'm solving it. So it's going to be y equals 5 times 70 minus 100. 5 times 70 is 350 minus 100 equals 250, if we're forgetting where that comes from. And then the last one, let's pick a value on the other side of 50. 20. Sure, 20 works. What's my profit going to be if 20 kids show up? 0. We have broken even at that point. Anything less than 20 kids showing up, we have a problem. So, let's graph it. We've got an empty grid here. How do you want to set this up? Carolyn has a thought. That hand shot in the air.
I would put get the negative 100, which is alpha, so we need to get at least negative 100, so the graph is there.
You want to go all the way to negative 100, okay. Where do you want to put that?
Pretty much in the left corner.
Bottom left corner? Okay. So if down here, which means this section right here, if we're putting it in the bottom left corner, this is where we're putting our y-axis.
Yeah.
Why is that a good spot to put our y-axis? Because you can't have negative students. So it makes sense that we would put our y-axis right along the left-hand side because we can't have any negative values for the number of people who show up. So we want, you said you wanted negative 100.
Yeah.
Okay. How are we going to go up by? Okay. Sure, we could go up by 50s. It's going to give us negative 50. Oh, wait. Every 1 is 50 or every 2 is 50? Every 2? Okay. So that's negative 50. That'll be 0. This will be 50. This will be 100. That's 150. Oh, I oopsed. Let's just, make something up. 250. I should have done every 1, but that's okay.
Yeah, and
And then we've already, now our x, or our x's set is already determined for us. There we go. So now, how do we want our x values, or the scale on our x value to look? We go up to 70 students, yeah. So yeah, we could do 2 squares is 10. Does your grid have to look exactly like this? No, it does not. But Carolyn's made some really good decisions here about how to set this thing up. It doesn't have to look exactly like this, but it certainly could. So let's put our data points now on here. We have a point here at 20 and 0. We have our point 50 and 150. And we have our point 70 and 250, which is just 1 square over the top of the graph. And now, does it make sense to connect those points? Sorry? No, you are right. Because we can't have fractions of students, so it doesn't actually make sense to connect these points. So what do we call it if we can't connect the dots? It's discrete. But what we could do is we could add some more points in here really easily using our straight edge. What other points does it look like are going to show up on our graph? Well, that point's going to show up. It's kind of maniacal. That one, 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 that one. There's a whole bunch of dots we could put in there, but now at least we've got some sort of idea of what the trend on the graph is. Because yes, connecting them would be a bad idea. How many students have to attend to make a profit? At least? How many? 21. Or we could use an inequality to describe this. Students need to be what? Greater than 20. Or you could say students are going to be greater than or equal to 21. Because you cannot have fractional students. And the understanding here is that students are going to be whole numbers. So it's either going to be greater than 20 or greater than or equal to 21. That's how you're going to get your profit. Love it. See, you're putting everything together. Flip the page, let's do one more, and then I will free you to work on all of it. Okay. Unit 4, Lesson 3, Example 2. Here we go. So, Sandeep. I don't know who this person is. But Sandeep is running an average speed of 10 kilometers per hour. Sandeep. No, this is a person's name. This is a person's name is running at an average speed of 10 kilometers per hour. How do you relate their speed, 10 kilometers per hour, with how far they've gone and how long they've been going for? Danny.
For the distance, if it takes them, if they travel 1 kilometer, it'll take them an hour, or 2 kilometers, 2 hours. Like, I don't know how to explain that. You have the independent variable.
Yep, we have some dependent variables. Think back to chapter 3. The equations where we did word problems relating how far, how fast, and how long. What was the equation that we used for how fast, how far, and how long? Distance equals Shyla? D equals? What's the equation? The V and the T. In this case, it's D equals V times T. If I know the V, is this a linear equation? What's the exponent on the D and the T? 1. So is it linear? Yes. It's beautiful. So what's the equation that's going to relate the distance that Sandeep has traveled and the number of hours she's been running for? Well, D equals 10 times T. I want to stay away from Y and X right now. Which one of these is the independent variable and which one is the dependent variable? The way it's set up. D is dependent, T is independent. So T is going to go right here in the X column. D is going to go right here in the Y column. And now let's create some table of values. What is a good initial time to choose? Sure, we can pick 1. After 1 hour, how far has Sandeep gone? I take my 1, I plug it into this equation. 10 times 1 is? I'm hearing everyone say 10. Give me another time. I heard 2 and I heard 5. After 2 hours, Sandeep is gone. After 5 hours, Sandeep is gone. I feel like that would be difficult to maintain that pace, but Sandeep's going to do it. So let's graph it. How do we want to set up our graph to reflect this chart? Sorry? The very bottom corner is going to be, this could be 0, 0. Why is this a good spot for 0, 0? You can't run negative kilometers, and you can't run negative time. So putting 0, 0 on the bottom is a pretty good way to set this up. So now let's draw our axes in there. What's my scale going to, oh, remember, y value, or the dependent variable goes on the y-axis, so this case it's going to be, my d values are going to go up there, and my t values are going to go down here. You don't have to label them x and y, you have to label them with the variables we've chosen to use, and we chose to use the variables d and t in this question. So what's my scale going to look like now? We have to pick a scale that reflects the spread of the data, and it probably wouldn't be a bad idea to go look ahead and see what kind of questions they might ask us after our graph has been made. So based on what you may or may not see on the page, what do you think might be a good scale for this graph? So instead of talking about things going up by halves, I could make how many squares equal to 1 in the time axis? 2. I could just go like this. I say, well, 2 squares is 1 hour. So it's going to look like this. And then we have the half hours in between here. But labeling the halves, that just gets finicky and irritating. So I would opt to write it like this instead. You could. I would never say bad, wrong, don't do that to mark the halves. It's just not as pretty, and so I'm not going to do it. Because, you know, sometimes a mathematician likes the aesthetics. Want our graphs to be pretty. And then the distance axis Yeah, go up by 5 or 2 squares equals 10. That works. Yeah. Again, to keep things neat and tidy, if we're going up 1 square is 5, I'm going to label every 2 squares as being 10s. Which takes us all the way up to 75 at the top there. And now we can connect our dots here. You said 1 and 10, 2 and 20, 5 and 50 is right there. 0, 0 can be included. That's an obvious one. If you haven't run, you can't have gone anywhere. Does it make sense to connect these dots? Yes. Why? It's not about the distances. We don't care about the distances as much. Is the independent variable allowed to be whatever fraction we want it to be? Yes, and that's what we care about. Because our independent variable can be whatever fraction of whatever we want it to be, that's the one that's going to determine whether or not I can connect these dots. So I can connect these dots. So we're going to get something that kind of looks like that. Assuming that Sandeep never gets tired, which I seriously doubt, at the half-hour mark, how far does Sandeep run in 0.5 hours?
Oh, he's running too.
She is running, yes. She's running. Okay, careful. Careful. Hey, stay with me, guys. I'm almost done. This is the last thing I'm doing, and I'm going to give you some work. How do we figure out how far Sandeep runs in half an hour? How do we figure it out? You could either do what, Carolyn? What's one option? Read it from the graph. How would you read it from the graph? On the t-axis where it's a half, okay. Go up where it hits and then go over. What's the distance on this line here? That's 5. Or 10 meet. You had another way to deal with this. Yeah, you could go back up to the top here and plug it into the equation that we generated at the beginning. D equals 10 times 0.5, so that equals 5. We can either use the graph as a tool, or we can use the equation that we generated as the tool. And then the last one, how long does it take her to run 15 kilometers? How are we going to go and do that one? If we're reading it off the graph, where's 15 kilometers on the graph? Right here, between 10 and 20. Good. And then what? Go over to the graph and go down to my time. How long does it take her to run 15K? 1.5 hours. Or we could do what 10 Meat suggested earlier and plug it into our equation. This is my equation, D equals 10T. Where does the 15 get plugged into? Goes in for D. So 15 is equal to 10 times T. To solve for T, what do I do? Divide by 10. Divide by 10. T equals 1.5 hours. See, it's just an application of all the stuff that we did before. We're just now adding in graphing. Cool? Comments, questions, concerns? If there are none that anyone wants to share publicly, I am assigning this piece here, page 171, 11, A to D, and 12 to 15. You will find these questions here. 11, A to D is right here. And that's not true. I want you to do all of 11. I want you to do E and F as well. Oh, whining. So much whining. All of 11, do E and F as well. And then it says 12 to 15. Basically, you're just doing 11 to 15. I'm just going to change it, make it nice, make it cleaner. Forget all this craziness. You're doing 11 to 15. If you need graph paper, I have more. Lots of graph paper for you guys. 11 to 15 means you're going to have to make 11, 12, 13, 14, 15 graphs. By 11 to 15, I mean 5 graphs. So if you can fit that on one, cool. Otherwise, I have more graph paper for you right here. I do not. That's why I have it. If anyone else wants graph paper, can get up and get it themselves. Right there. I'm going to go photocopy some more. Okay, get to work. Okay, I got more graph paper up at the front. There's a lot of you that are not doing the things. Use the time to do the things so that I may assist you with the things.